So when we think about where we've been, we've had these loose confederations of resources tied together. They were kept private. We spun up firewalls to keep the bad guys out. You know, port 80 and port 443 were primarily left open. But for the most part, we've perimeterized these installations to a point that we've kind of separated inside and outside. We all know that ultimately that model doesn't work so well anymore in the age of collaboration, especially what we heard from Mark and Vivek. So what people ultimately say to describe this is that the perimeter is disappearing. And I maintain, actually, that that's not true. I maintain that the perimeter is multiplying, but that ultimately the diameter is collapsing. And what I mean is every machine, every one of these VM packages itself is its own little microperimeter. And so when you take that to the logical extreme in cloud computing, where now I have all these little VMs and workloads that can take advantage of scale, then what I end up is with potentially hundreds or thousands of microperimeters. So we used to think inside and outside, one or a couple of hundred, maybe even firewalls worldwide. That was a big deal. We even got away, kind of cycled through endpoints, and we've gotten used to manage certain things a little inefficiently, but certain things at scale. But when we think about securing the perimeter or perimeters, cloud really stretches this to its extreme. And we've gone from this notion of singular, insular, single-function servers on specific platforms to these heavily virtualized fabrics, where in these fabrics, what we've essentially done is to take advantage of scale-out capabilities. These little VMs just basically will soak up as much resources that you can throw at them as possible and then shrink back down to efficiently utilize infrastructure, right? But when you think about that packaging, as we scale out, the VM then becomes that de facto perimeter. It becomes, at least from an infrastructure as a service perspective, the thing that we need to start thinking about, because now I can take one of these packages and I can efficiently deploy it pretty much anywhere. Even if it takes a little bit of manual process and we're not quite there with orchestration and provisioning yet in terms of full automation across multiple clouds, in a cloud like Amazon, you can take a workload and basically pop this bad boy across anywhere on the planet that services your requirements. So we have heavy amounts of automation focused on that package, but the only thing that doesn't scale is security, almost by design. We expect that, for example, when we move to cloud, that somehow there's this magical meat cloud in the middle of it that administers things, right? That would be us. And the challenge here is that we have all the technological capabilities to do this. We just haven't kind of pushed forward. We haven't had the impetus to start thinking differently about how we're going to do this. So what's holding security back? You know, what is preventing us from being able to move forward in ways we need to? Why do we have such a lack of automation? Well, when we think about this problem set, we've got to think about the stack. If you think about cloud computing, I like to chop stuff up into cute little buckets and names. So we have infrastructure with compute, network, and storage. We have metastructure, which are protocols that ultimately bind or ultimately decouple and abstract infrastructure from the applications that ride on top of them. And then sitting on top of that is information, right? Information and data. So when we look at these four components, the challenge is that each one of those things in the stack, when we think about what we talk about or what we mean when we say security, people use the word information security a lot. Well, for the most part, we don't practice information security. What we practice at each layer are a discrete amount of network, compute, and storage security. We practice application security and information security. So it's fractured by its very nature. So that organizational kind of cognitive dissonance that we have in terms of tools, technology, and approach is even more amplified when we think about how we break down the stack and the delivery model, because not each one of those things is run by the same people using the same tools, even within security. So we have a very fractured approach to this. And as we think about the stack and kind of infrastructure as a service and where the consumer versus the provider is responsible for security, we think about platform as a service or software as a service. The things on top, when we think about infrastructure as a service, we really are concerned with network, host, and storage security, which is strange because most of the stuff we get to control is actually above all of that. When we think of platform as a service, we worry about the application being secure. When we think about software as a service, we worry about the provider securing our information. But when we think about these disparate approaches, I want to focus again, to make this easier to digest, on infrastructure as a service. How we ought to think about security in this regard is, in many cases, we have to deal with compliance as it relates to contracts and the provider's ability to give us visibility and transparency below the line. But most of our focus, if we're a consumer of an infrastructure as a service, lies at this bundle, the VM boundary. Right? That's where we have to focus. So people freak out because they say, oh my God, you know, I have no visibility and transparency, and I still have to do all the same stuff. Yeah, you do. But in many cases, there's no link between the two. And what they often forget is they say, well, I have no compensating controls. I'm worried because I don't know how to get from here to there. So it's actually, from the perspective of what we think, I think it's actually a little bit easier. We have a cloud model that talks about the stack and the ontology associated with it. We have a catalog of security controls, and we ultimately have a set of compliance frameworks that say this is what I need. We can actually work back remarkably easily to figure out where gaps lie and how we ought to plug them based on whether you're compliance-driven, infrastructure-driven, or controls-driven. Right? It's not that difficult. What's difficult is ultimately figuring out, when you look at these layers, which part you might be responsible for, even though that line seems to be clean. And what I mean by that is actually we don't have too little security, we have too much security. And this diagram illustrates, for example, a cloud provider who may have a whole set of cloud infrastructure from a hardware perspective, a whole set from software, with a whole slew of security functions over to the right. DLP, firewall, intrusion prevention, intrusion detection. And then sitting in a VM on top of that, we actually have the exact same set of controls that in a VM that an administrator, security team, or network administrator might operate. They could actually be the exact same tools, the exact same pieces of software and hardware, or in this particular case, software. But you'd never know it because the stuff in the bottom never communicates with the stuff in the top. There's no exposure. So what we have is this. Loosely aggregated sets of security capabilities, and what we need is this, programmatic orchestrated security. I need to know that I can take advantage of these APIs, which is a precursor to calling anything cloud, in my opinion, and be able to use the same sets of APIs and telemetry to at least make stack components aware of one another. So, for example, when the infrastructure is under attack that the cloud provider is managing and securing, that my applications can be given access to the fact that that attack is occurring. Today, we're blind. Today, you could be DDoSed to death, charged $7 million for a bill for traffic that was ultimately sent to your IP address for which you never even necessarily knew you were under attack, right? That's silly. So APIs, in this particular case, give us the ability to get there. So how do we get to this level of automated security? First of all, we have to kind of design for scale around rethinking about how and where and why we deploy security. We have to think about how we deal with traffic steering and service insertion. So when a new security function is needed, we can easily add it as a service, whether that's in the software platform or infrastructure as a service, by, in, or for the cloud. We also need to tie back the physical and the virtual where appropriate to make sure that things can signal up stack. We need to standardize on common telemetry across policy and policy across platforms, more intelligence shared between the infrastructure and the applications. In many cases, given the deployment model and the abstraction and dumbing down of the network where I can't plumb network-based controls, I may need to go back and essentially redeploy guest-based footprints, which comes back to an issue of scale, but we also need to think about this holistic stack I talked about. And then leverage hypervisor and platform APIs across software, platform, infrastructure as a service. Now, this seems like a big set of we just need tos, and it is. But the reality is the majority of these security technologies already exist. They just need to be federated and integrated properly. So if this is kind of where we need to get to, and we have a number of the capabilities that already exist here across the industry, we have ways of describing vulnerability, we have ways of defining threat, we have ways of doing upstream telemetry and signaling. How do we get to that point? So step one is that you can't just sit there. It's not going to automate itself, right? You still have to do a lot of the hard stuff, and you cannot just expect that a single-sourced provider of service is going to be the same set of people that are going to secure your service. Remember defense in depth? I mean, it's a wolf guarding the sheep problem, right? Ultimately, if the stack providers have all these great solutions, all these great security solutions built in, but you can't extend them, that's a problem, okay? Ultimately, step two, you have to recognize and accept and move on that the classical DMZ design pattern is dead. As we've moved from physical insertion of devices to clustered capabilities across heavily virtualized platforms, we end up with something that looks like this in platform as a service, where we have messaging queues, service buses, brokers, role definitions. That looks nothing like the other two things. And we're evolving in that path, and our tools aren't, right? So that model of multiple thousands of potential perimeters is really, really, really problematic in this scenario. The good news, however, is that you also don't have to do everything yourself. In between this kind of hybrid set of adoption capabilities, there are a number of brokers today that add the capability to automate certain functions that you may not think of as security today, but many security appliances are now virtual machines. So if it's a virtual machine, I ought to be able to automate it in the same way that I can automate a workload. So if you can't do it yourself because you don't have the technology tools or teams, there are brokers like Instratus and RightScale who can help you provision those things for you. You don't have to do everything yourself. However, I will suggest that when you go to your vendors, hardware or software, cloud service provider or security provider, you need to demand the fact that all of their products should be programmable, orchestratable, and governed by APIs. If they're not, and you're using CLIs and GUIs, that's death. Okay? If that's the only way you can manage products, that's death. You will never get, and that product will never help you get to the point you need to move forward. Next thing we need to do is we have to become nimble as an industry, agile and flexible, and understand how provisioning tools like Chef and Puppet and CF Engine, or even scripting languages like Python, are being implemented to actually provide the majority of this cloud automation that takes place in these cloud stacks. Once you learn that, what you'll find is a number of the tools, even if you have to do like nasty in-the-weeds kind of CLI meta translation between an API and a CLI, you can actually automate a tremendous amount of security today, even existing products, if you adopt this kind of agile code as infrastructure view of the world. The thing we also need to do is squash inefficiency and maximize efficacy as it relates to audit and compliance. This is where cloud audit comes in. Right? Being able to provide consistent interface and namespaces to allow providers to dump information into commonly named repositories and then use automated tools to extract it to basically gather data regarding assertions of audit and compliance. We're releasing here at the show version 1.1 of Cloud Audit, which has the updated set of namespaces out of the Cloud Control Matrix. Look for that shortly on the website as we finish the packaging for the Python scripts that allow you to, as a provider, take these namespaces and deploy them. But this is a way of automating something that otherwise we pay a lot of money and a lot of time for people to basically sit there and gather the same sets of information, that duplicative sets of requests that Vivek was talking about. Audit and compliance is one of them. Right? And the reason we need to automate this is this model simply doesn't scale. Right? The guy in the suit that comes around and asks you questions doesn't scale. We need to ultimately make friends with developers. And this isn't automation from the perspective of the classical sense, but it's a way of stopping viewing this developers are evil, security guys are saviors view of the world. The reality, we're so intertwined today. And maybe security guys don't know anything about programming, program guys don't know anything about security. The reality is we all need to know something about automation because both of our worlds are being automated in ways that we've never seen before. So these elements, while I've kind of rushed through them and there seems to be a lot there, again, we have a tremendous amount of capability. The technology exists for the most part. Some of the deployment models are rough. Some of the standards aren't there. But the reality is a lot of this is based on a feedback loop that we as the consumer need to pressure in terms of vendors besides the stack providers to be able to essentially pick up and deploy so we don't get locked in. So that security control moves with the workload. So if I say I need a level 3 cloud, that means I got to have this in place, that I'm relatively assured that even though they may be customized implementations of a particular cloud stack, that my security policy is enforced regardless of technology. That can totally happen today. It already does. Right? It just takes a push. So ultimately, when we think about the punchline here, to truly leverage cloud and all of its elasticity and its flexibility, security has to scale, has to be automated at the same level as the workloads that it's designed to protect. Today, it's not. We really cannot afford to settle for the same old crap, which is where this whole thing came from in the first place in terms of the topic and title. Right? We say no to Commode computing. Right? Don't accept it, and push more. So thanks very much. That's the end of my presentation, exactly on time.